In this video, we will talk about another design pattern called facade design pattern. Okay. So, facade design pattern, it comes under structural design pattern. Okay. Now, let's start with a simple example. Okay. Now, let us suppose there are multiple interfaces that are present in your system. Okay. Now, let's say you consider an e-commerce system. Okay. In the e-commerce system, whenever you want to place an order, what you will do basically, first you will add items to the cart, right? You add items to the cart, and then you will enter your payment details. After that, the payment will be made, and then the order will be placed. Okay. So first add items to the cart, add the address, select or add the address, and then add the payment details, make the payment, and then place. Once those are done successfully, then an order will be created in an e-commerce system. Okay. Now for adding items to the cart, there would be cart service. Let us suppose this is all an e-commerce system. Okay, e-commerce subsystem. Now what happens is, this is a cart service, this is a payment service, and then this is an order service where order gets created. And the other thing is, maybe you have a profile information also, you have a profile service. So when you are placing an order, first you have to talk to this particular cart service. Okay, and then add items to the cart. So first step is add items to the cart using this cart service. Then using the profile, you can either select or add a new address. Post that, enter your payment details and make the payment. And the fourth step is create an order. Okay. Now this is one of the systems. This is one of the system or an example you are talking about. And let us consider, now you want to develop a home theater system. Okay. Now in the home theater system, you will have the player, you will have the tuner, and then you will have the popcorn popper, right? Whenever you are watching a movie, you require popcorn also, and you have a screen, projector, popcorn, lights, and everything. Like at your home, if you are setting up a home theater, what you will do is, you will have all these items, right? All these systems set up. Now let's say I want to start a movie. Okay, I want to watch. Now the system is set completely. Now you have a popcorn popper, you can go to that popcorn popper and you can fetch the popcorn, and you can set the screen settings, and you can switch on the projector, you can switch on the lights or off or dim the theater lights. There is a tuner, there is a player, right? You can have the amplifier also in the home theater system. Now if you want to watch the movie, what you have to do, these are the steps that you have to perform manually. Like you have to first turn on the popcorn popper, then first turn on the popper, and then while you are watching the movie, people usually dim the lights. You dim the lights and you turn the projector on, put the screen down, and then set the projector input to the player, and then you put the projector on the widescreen mode, and you can turn the sound amplifier on, and you can set the amplifier to the streaming player input, and you can set the amplifier to surround sound, and then you can start after turning on the streaming player, you can start playing the movie. So whenever a person wants, like the whole subsystem is, the whole home theater system is set up. You have the popcorn popper, you have the tuner, you have the player, and you have the amplifier, and you have the projector, screen, lights, and all. But like you invite your friends, okay, and then all your friends are sitting in the room to watch the movie, and you like to switch on to watch the movie. What you will do, you will first go to the popcorn popper and you do that, and then you dim the lights. So it takes almost 5 minutes to time doing all these steps. Whatever the steps that are present here, it takes almost 5 minutes to do all these things. After setting up all these things, then you will be able to watch the movie. And by the time you do all these steps, people get tired, and people should have knowledge about all the subsystems as well, like how to turn the popcorn on, how to dim the lights, and people should have knowledge about all these interfaces as well. Okay, there are multiple classes that are present, and people should know about all this to watch a movie. Okay, and here as well, whenever you are placing an order, you should know all these things. You should call the cart service to add items to the cart. You should call your profile service to fetch the address, and then you should call your payment service to make the payment, and then you should be able to call your order service to create an order. So all these steps has to be by you, because there are like it has the interfaces. Okay, you just invoke a single method these interfaces, but ultimately, since there are multiple interfaces which are coupled, here if you see card service, payment service, they talk to each other. Okay, so once the payment is done, it will update the card that the payment is done, and then you go and place the order details. So all these services are integrated. Okay, they have the communication that happens. And even if you see here, project like streaming player, it's using the projector, and amplifier using the player and the tuner. So there are multiple systems that are present, and to make a task done, ideally, like if I am watching the movie, the client needs to interact with all these systems or all these interfaces to make a single task done. To watch the movie, there are multiple things that are involved here, and to place an order, to place an e-commerce order, you have to do all these things. Okay, now you might wonder here, anyway it gives you an interface. Okay, but still you need to invoke method, though you don't have though you need not invoke the subclasses that are present inside the card service, or the subclasses that are present inside the payment service. Okay, maybe in the inside the payment, under the payment service also, you might have different kinds of payment types, right? Though you need not know all those details, but those are all abstracted, or those are all put in a single payment service, right? At least you should have knowledge about at least, right? So here what is happening is, people has to do lot of make a task, to make a task work, right? Or to do a task, you have to do multiple things here. So now what if you imagine you have a higher level class. So though you have multiple services that are present, or multiple interfaces that are present, and instead of you talking to all these subsystems, let us suppose you define a higher level interface here called Facade. Okay, now this could be anything, e-commerce Facade, order Facade, anything. And what you can do is, you can put a method called place order. Okay, place order method. Inside this place order method, now client like not invoke all these calls, client can invoke just place order method. Now inside this place order method, what you can do is, you can call cart service dot add items to the cart, you can call payment service dot make payment, and you can call profile information dot get address, and then you can call order service dot create order. So all these steps are encapsulated inside the place order method of the Facade. Okay, and you can expose methods for your different tasks. There could be another task where you will update the inventory of the items. You can put another, like in ideally what you have to do is, you have to talk to inventory service, and then you have to increase the quantity of an item, and then you might need to publish that data to the backend stream so that the reports are updated. So instead of you going to the inventory service and update the quantity and then sending the update to the backend systems, what you can do is, maybe you can have one more method called update inventory, and inside the update inventory, Facade can write an implementation for update inventory, like talk to inventory service to update the inventory, and publish to backend streams to update the report. Okay, now if you develop an interface, higher interface called Facade, and declare methods and implementations there, so basically for a multiple task, or you might need an interaction with the multiple subsystems, now client, instead of doing all those, Facade interface is taking all that responsibility, and it is method called place order. Now client just needs to talk to the Facade pattern and then invoke the place order method. This is so simple, right? What Facade pattern is doing, it is just providing interface which will talk to your subsystem to accomplish a task. need not talk to the complex subsystem is present. And even here for the home theater also, instead of you going and turning on the popcorn projector screen and setting the screen mode and everything, what you can do is you can develop a home theater facade, okay, and this facade will talk to amplifier, this facade will talk to tuner, and this facade will talk to streaming player, and it will talk to all subsystems or all the interfaces that are present. And whenever you invoke watch movie, what it will do is whatever things you are doing it here, it will encapsulate all those things inside the watch movie method. And whenever you end movie, what you have to turn off the projector, you have to turn off the amplifier, and you have to turn off the popcorn popper, and all these things also takes time while you are ending a movie. So that also might take about 5 to 10 minutes, and that is an overhead for the client who is using that, okay. So instead of client interacting with multiple subsystems, what you can do is you can develop a higher level interface which will talk to these lower level interfaces, and then it will accomplish a task, okay. Now let us see how the facade worked here, okay, for the system. And not just the home theater and the e-commerce, multiple applications that are present in the libraries. So usually if you see libraries, what it does is it will just give you one method. Like if you want to get a JDBC connection, what you will do, you will just do the JDBC dot some get connection by passing some URL. Inside it, what it will do is it will talk to multiple subclasses and it will give you the connection. And also if you want to insert something in the database, what you have to do, you have to, like let's say you are making a banking transaction and you have withdrawn an amount of 1000 rupees. So what it has to do, first it has to debit, you are transferring amount from person to another person. It has to debit amount from one person's account and then it has to credit to another person's account. Now if there is no facade pattern, what you have to do, you have to talk to both accounts and then do the changes respectively. But if you have a facade pattern, you can just invoke make transaction method and give the sender and the receiver details, and all the logic that you were doing before can be encapsulated in the facade pattern. So there are so many examples for the facade pattern. And if you see the home theater facade pattern, what has happened is, so if you see here home theater facade pattern, of all the subsystems, okay. So here if you see, you have this home amplifier and tuner, streaming player, screen projector and all, right. What it will do is, using the composition, it will hold references of these amplifiers and all, and while instantiating the home theater facade, you have to pass all these references, okay. Now whenever you invoke watch movie method, what it does, it is doing popper dot on popcorn popper, it is oning the popcorn popper and then it is popping out the popcorns, it is dimming the lights, it is bringing the screen down, it is like switching on the projector, setting the screen mode, and then player on, player dot play movie. So all these steps before, you were interacting with all these interfaces, projector, screen, theater, lights, popcorn popper, and you were doing all these steps manually. Now facade pattern, what it has done is, it says that I am a higher level interface, I will talk to my subsystems and I will do all the things. You just invoke, you just say which movie you want to watch, okay, and I will do all the things on behalf of you. And while ending the movie also, what it will do is, it will turn on the lights, it will turn off the popper, it will bring down the projector, it will bring down the amplifier, it will do all these things, okay. Yeah. Now like if you think about the facade pattern, what it is doing is, it is providing a higher level interface which will reduce the interaction of the client with multiple subsystems. And the facade pattern also one of the design principle, that it should have the classes should have knowledge. So when I say the least knowledge, that are present in the facade pattern, and he need not know anything, like he need not know anything about the subsystems. So client can talk to facade and facade can talk to the subsystems. Now client is not, so here if you have levels like client immediate this facade and facade immediate friend is the subsystems. Now what this principle of least knowledge says is you always talk to your immediate friends, not the friends of friends. Okay, now you can talk to your facade pattern, you don't talk to your facade. Okay, you like people should have the least knowledge. Instead, now let's say you don't have the facade pattern and you have the subsystem here. Now what happens is, if a person makes, if there is a change to the card service, now I have to update my logic of invoking the card service, and there can be multiple clients, right, who is talking to the card service, and all the clients has to change that. But if you have a facade pattern, what you can do, you can directly update in the facade pattern and all the clients change it. Facade pattern takes care of those implementation. Now you should talk to only your, then whenever a change happens, you will, whenever a change happens to your subsystems, you need not make your, okay, because don't make your system as a loosely coupled. If you have multiple classes, then it means that those are following the single responsibility principle, right? Make your classes loosely coupled so that if you so that at the facade pattern, only the facade pattern may change it. You need not change the implementations that client has like the client has written to place an order or for some other services. Okay, now even you can consider this with the home example also. Now if a person is looking if a person is looking a house outside, what they have is they have nicely painted walls. Okay, but inside walls and all, you have multiple plumbing work that is there. You will have the electric wires, okay, and you will have the pipes, okay, you will have the bricks and everything. What you can do is, if you just switch on the light and all, or if you just, even for the cylinders also, what happens is you can switch on just one, you can switch on switch and you get the gas, right? And even if you can turn on the lights internally, it will do everything. You need not go, like you need not do any you need not talk to internal systems. You can just switch on the light and all the lights will be switched on, and if you can turn on the tap, your water will come. All the logic that is present inside it, right, though that is not exposed to us. So it has, whenever you switch on the lights will talk to which system, like which plug it has to pass the current and all, it will take care of that. You need not know about all the implementation details. Now whenever you say that you are developing a higher level interface called facade pattern, and if the client wants to talk to its subsystems, talk to only facade. No, it is not the case. Subsystems are still exposed to the client, but by using the facade you can work. Okay, now if a client really needs to talk to one of your subsystem, you can still do that. Okay, you are not touching that. Subsystems are still exposed to the clients. Okay, but you are just giving an additional layer on top of the subsystem, which can be used by the client to make its life. Okay, now let's see the class diagram of the facade pattern. Okay, so what happens is, in the facade pattern you just have a client here. If you can see, right, you just have a client and you have the higher level of the facade, you have the facade defined here, facade interface defined here, and you can have your methods defined here and implementations, and that will talk to your subclasses. Okay, yeah, that's it about the facade pattern. This is so simple pattern. Okay, what it is doing, it just provide a simple and the unified interface which can talk to the subsystem and makes your life easier. And let's see the definition of the facade design pattern. So facade design pattern, it provides a unified interface to a set of interfaces in a subsystem. So if you see here, these are the set of interfaces, right? Now on top of these subsystem, it has implemented a facade pattern. Okay, it provides a unified interface to a set of interfaces in a subsystem, and facade defines here to use. So to use this e-commerce system or the home theater, you can just talk to facade pattern. And people might think that you just need to have a single facade pattern for one subsystem. No, it is not so. You can have multiple facades. Based on your requirement, you can define multiple facades as well. Okay. Yeah. That's it about the facade pattern.